Today we're going to talk about different forms of linear equations. There are three forms of linear equations that are really helpful to know, and we've studied two of them a lot this year in Math 1 CP. The first one is slope-intercept form. Slope-intercept form looks like y equals mx plus b, where m is the slope and b is the y-intercept. Remember that slope, which we also call the rate of change, tells us the change in y over the change in x. So sometimes you might see m written as delta y over delta x, where delta means change. You might also see slope calculated using a formula, and that formula is going to be m equals y2 minus y1 divided by x2 minus x1, and those are just labeling if you had 2 points to begin with. So it's taking the y coordinates from both of the points and subtracting them, and then the x coordinates of both of the points and subtracting those. So for example, let's calculate the slope of the line that passes through the points -4, 3, and 2, 12. So to do this, I'm going to show you two ways. The first might be, I might just put them into a table and say x, y, and then have -4, 3, and 2, 12. Now if I want to calculate slope, I want to know the change in y divided by the change in x. And I look at the change from 3 to 12, I added 9. The change from -4 to 2, I added 6. So because of that, I can do my change in y was 9, my change in x was adding 6. I can reduce that to be 3 over 2. Another way that you can do this is if you want to use the formula m equals y2 minus y1 over x2 minus x1, that's fine as well. I'm going to label my points, so this is going to be my x1 and my y1, and then my x2 and my y2. So now I'm just plugging numbers in. So I have m equals y2 is 12 minus y1 is 3 over my x2 is 2 minus my x1, which is -4. Don't forget you have a minus a negative in there. So 12 minus 3 is 9. 2 minus -4 is positive 6. So I'm going to get 3 halves either way. The second example says, write the equation of the line graph below in slope-intercept form. So I need to find both my slope and my y-intercept. I can see that my y-intercept is 2, so b equals 2. And I'm going to choose another point that's going to help me write the equation here. So I see I'm going to choose this one. This point is 4, -1. So for me, I prefer to put them in a little table again, and I have the point 0, 2, 4, -1. So if I want to know my slope, that's my change in y divided by my change in x. My y goes from 2 to -1, so that's -3. And my x goes from 0 to 4, so that's adding 4. So this is -3 divided by 4. So now I have my m, I have my b, so my equation is y equals -3 over 4x plus 2. All right. This last example says, write the equation of the line that passes through the points -4, 3, and 2, 12 in slope-intercept form. Okay, so if I want to do this, the first thing I must do is find slope. And you'll notice that we did this already in this box up here, so we know that the slope of the line that goes between these 2 points is 3 over 2. The second thing we need to do is solve for b. And the way that we do that is that so far, I know my equation will look like y equals mx plus b, but I know m. So I have y equals 3 halves x plus b, and I want to know what b is. The way that I can do this is I can choose one of my points, and I can plug it in. I'm going to choose to plug in -4, 3. -4 is my x value, 3 is my y value. So I'm going to plug this in. So the y value was 3. Equals 3 halves times -4 plus I don't know what b is. And now I can solve for b. So I have 3 equals 3 halves times -4, that's -12 over 2 plus b. Negative 12 over 2 is just negative 6 plus b. So if I solve this, I'm going to get 9 equals b. So my third step will be write the equation. And I know that I have m equals 3 halves. I have 9 equals b. So I have y equals 3 halves x plus 9. It's the equation of my line. And if I want, I can check. And the way I can check is that I'm going to use my other point, 12, and I'm going to say this is the x, this is the y, and I'm going to plug it in. So if I have 12 equals 3 halves times 2 plus 9, 12 equals 6 over 2 plus 9, 12 equals 3 plus 9, and 12, in fact, does equal 12, so I did this correctly. The next form that we studied this year is standard form, and standard form looks like this. ax plus by equals c, where a, b, and c are constants. So just regular old numbers. You can find the x and y intercepts of standard form equations by plugging in 0 for x and for y. You can also isolate y to convert an equation from standard form to slope-intercept form. And we practiced both of those this year. So graph 2x minus 3y equals 12. I forgot to give you a little graph on here, so we're going to sketch it. And I'm going to do that by finding x and y intercepts. So remember, an x-intercept is on the x-axis. And if it's on this line, do you see how it didn't really go above or below? It's on the x-axis. That means that the y-coordinate is 0. So I'm looking for a point where I don't know the x-coordinate yet, but I do know that the y-coordinate is 0. And if I'm doing a y-intercept, it'll be on the y-axis. And anywhere on this y-axis, any point that I draw will have an x-coordinate that is equal to 0. So what I'm thinking to myself is, if I plug in 0 for y, so I'm going to do 2x minus 3 times 0 equals 12. 3 times 0 is just 0, so I don't really even need this part. So I really just have 2x equals 12. If 2x is 12, that means that 2 times something is 12. Well, that something has to be 6. I can do the same thing to find the y-intercept. So I'm going to plug in 0 for the x. 2 times 0 minus 3y equals 12. But 2 times 0 is just 0, so this is really just negative 3y equals 12. And even if I'm not sure right here, I can say, okay, well, negative 3 times y is 12. I don't know what y should be. Maybe I could just divide by negative 3. I'll solve for y. So I would get y equals negative 4. And now I can make myself a little graph. So I have my y-intercept is 0, negative 4. My x-intercept is at 6. Okay? And there is my sketch of my graph. And if I want to convert this into slope-intercept form, all I'm going to do is solve for y. So I'm going to subtract 2x on both sides, minus 3y equals, and I'm going to put this negative 2x first. And it's a plus 12 because the 12 is positive. I'm going to divide by negative 3, and I have to make sure that I divide everything on that right-hand side by negative 3. So I have y equals 2 over 3x minus 4. And this should match up with my graph that we just made because it was the same equation. So I can see that my y-intercept is negative 4, which we found. And if I went up 2 over 3, I would be at 3, negative 2. And then if I went up 2 over 3, I would be at 6, 0. So this does seem to match what I just found. The last form of linear equations that we haven't studied yet is called point-slope form. And point-slope form can be incredibly useful because it's really easy. It looks a little funny, but it's very helpful. So to write an equation in point-slope form, all we need to know is a point on the line, so like an x and a y, and the slope, which is the m. Okay? And I'm going to call this x1, y1, so we know that they're actual numbers. So point-slope form looks like this. And this is a little funky, so it takes some getting used to. But It's y minus y1 equals m times x minus x1, where m is the slope and x1 comma y1 is a point on the line. You can convert point slope form to slope intercept form pretty easily by distributing and then isolating y. So I'm going to show you what I mean. So it says write the equation of the line that has slope negative 2/5 and passes through the point negative 3, 2. So m equals negative 2/5, and this is the point negative 3 is my x1 and 2 is my y1. So if I want to write an equation in point slope form, I'm going to do y minus y1 equals m times x minus x1. And all I'm going to do, my friends, is put in the stuff that I know. So I'm going to do y minus y1 is 2 equals, my m was negative 2/5 times x minus x1 is negative 3. So I'm going to put negative 3. And another way that I might write this, because subtracting a negative is the same thing as adding, I'm going to do y2 equals negative 2 over 5 times x plus 3. And here it is in point slope form. That's it. You could type that into Desmos and it would give you a graph of that line. If I want to convert this into slope intercept form, I just need to get this y by itself. So what I'm going to do, I'm going to distribute and then I'm going to add that too. So I'm going to have start with my equation. Okay, and first I'm going to distribute this negative 2/5. So I have y minus 2 equals negative 2 over 5x minus 6 over 5, because 3 times negative 2/5 is negative 6 over 5. Now, to get y by itself, I just need to add 2 to both sides. Okay, and reminder that negative 6/5 plus 2 is negative 6/5 plus 10 over 5, which is 4 over 5. So this will now become y equals negative 2 over 5x plus 4/5. And that's really nice because we didn't have to solve for this y-intercept. All we really had to do was just like use the numbers that we already had to rearrange this. So do you remember how annoying this process could be for solving for b, where we have to plug it in and then we have to solve and all of that? This one just might do it a little bit faster. Okay, then this one says write the equation of the line in point slope form. And to do this, to show you guys, I'm just going to pick some random point here. Okay, I'm going to pick this point and I'm going to pick this point. So I'm like, okay, cool, I've got 2 points. I might want to figure out my slope. I'm going to figure out the slope on this graph. Remember that my slope is my change in y over my change in x. So I'm going to look here. If I start on the left, you always want to start on the left. If I go down 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went down 9. And I went to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's plus 12. So my slope is negative 9 over 12, which is negative 3 over 4. And now I'm going to choose one of these points and write the slope-intercept form. So maybe I'll just choose this one. So this one was negative 4, 5. Okay, so this is my x1, this is my y1. So point slope form, y minus y1 equals m times x minus x1. Y minus, my y1 is 5, equals m, which was negative 3 over 4, times x minus negative 4. But remember, subtracting a negative, y minus 5 equals negative 3 over 4 times x plus 4. Great. Okay, so I'm done. I could also have used my other point to do this. And if I had used this other point to do this, this is the point 8, negative 4. Just to see, it would be y plus 4, because y minus negative 4, y plus 4, equals negative 3 over 4x minus 8. That's another form that you could use. You could use any of these. You could use a different point if you wanted to, and it would still be the same thing. It looks a little bit different, but if I were to simplify this, I would get the same thing. I'll show you one. So if I do this one, y plus 4 equals negative 3 over 4x plus negative 3 over 4 times negative 8 is going to be a positive, and it's going to be 24 divided by 4, so this is going to be 6. And then if I subtract 4 from both sides, I get y equals negative 3 over 4x plus 2. Okay, and you might remember that we did this already. This is the same graph. Let's see if it looks the same. Oh, y equals negative 3 over 4x plus 2. So this form still simplifies down to the same points, or slope-intercept form. All right, let's do this one. So we've got negative 4, 3, and 2, 12, and we want to write this in point-slope form, and then we want to convert it to slope-intercept form, kind of like what we just did here. So first I need to find m, and I need a point. So let's label x1, y1, x2, y2, and I'm going to do m equals y2 minus y1 over x2 minus x1. And y2 is 12, y1 is 3, x2 is 2, x1 is negative 4, so I'm going to have 9 over 6, which is 3 halves. Okay? Now I've got a point, so I'm just going to use this point, negative 4, 3. So I'm going to do y minus y1 equals m times x minus x1. So I do y minus 3 equals 3 halves times x minus negative 4, which is plus 4. So this is my point-slope form. If I had used the other point, I might have written y minus 12 equals 3 halves times x minus 2. That would be the same line. If I convert this to slope-intercept form, I distribute this 3 halves, so I have y minus 3 equals 3 halves x plus 12 over 2, which is just 6. So I can add 3 to both sides now to get y by itself, so y equals 3 halves x plus 9. And you might remember, we did this already. We did this on the previous page, so let's go look. Right here it said, write the equation of the line that passes through the points negative 4, 3, and 2, 12 in slope-intercept form, and we ended up finding it was y equals 3 halves x plus 9. So we got the same thing using different forms. It is perfectly acceptable, unless you are asked to put it in slope-intercept form, to leave it in point-slope form. In fact, when you get to calculus, this form is preferred. We don't like slope-intercept form as much because it's more annoying. This form is great.